All right, ladies and gentlemen, today it's 9.4, arithmetic sequences. So, quick little do now. Is this recursive or explicit? Well, if we notice, we have an initial term that they gave us, and then you see an n minus 1 immediately. So this is recursive, okay? Now, finding the first five terms, well, we already have the first one. So a sub 2 is going to be 2 minus a sub 1 over 2, and so we just plug and chug that. That would be 2 minus negative 2 all over 2, which gives us 4 over 2, which is 2. All right, so we got that one. Okay, the next one would be a sub 3, so it'd be 2 minus a2 over 2. So it'd be 2 minus 2 over 2, which gives us 0. Okay, we're done with that one. A to the fourth. And so from here we have, let's see, 2 minus a3 over 2, which is 2 minus 0 over 2, which gives us 1. And then a sub 5, it'd be 2 minus a4 over 2, which is 2 minus 1 over 2, which is just 1/2. And there we go. We found all the first five terms. Now, of course, I mean, they give us a formula, we plug and chug, and we get a list of numbers. But what if they give us a list of numbers and then they want us to create an equation? Well, here are two things you need to figure out, okay? There's the explicit rule and the recursive rule. Here's the basis of every explicit rule and the basis of every recursive rule. And so you need to figure out what A1 and D are, and then we would be perfectly fine. So for example, the beginning of this sequence is A1. So we know that A1 has to equal 29. Well, that's great. That's the beginning of the rule. And now we have to figure out what the letter D is. Now, D stands for the difference, okay? Or in other words, it's highlighted here in yellow, the common difference. I need to figure out what's the difference from here to here, from here to here, from here to here. Now, I don't know this one. This is pretty hard. But what about the difference from negative 71 to negative 171? Well, that's easy. You're subtracting 100. Then you subtract 100 again. And so it has to be common. It happens over and over and over. So that tells me that this has to be negative 100. So that tells me that D stands for negative 100. Okay, now let's work on the explicit formula. Okay, so explicit tells me to use the formula AN equals A1 plus D n minus 1. Okay, now of course we already figured out A1, so this is AN equals 29 plus, now D we figured out that's a negative 100, and then n minus 1 stays put because there has to be an n in your formula. Okay, and so then now from here, you just distributive property. So we just throw and throw. And so we now know that it's AN equals 29 plus, actually at this point now it's minus 100N plus 100. That's just distributive property. And then we simplify. So AN equals 129 minus 100N. This would give us any term we want, even the first term if you plug in 1. Now for recursive, that one's a little bit easier to build because the rule is AN equals AN minus 1 plus D, and then you just have to say that A1 equals a value. Well, we have those values. So it says AN equals AN minus 1 plus negative 100, so it'd be minus 100 because that's what D is. And then you just have to say that A1 equals 29. So recursive formulas are a lot easier to build, but explicit formulas are a lot easier to use, okay? So let's just remember that. Now let's do some examples. So example number 1, write an explicit and recursive for each one. All right, well, first of all, we know that A1 has to be negative 6, and D, well, let's figure that out. The difference between each of this is, let's see, they added 4. And then, oh, they added 4 again, and they added 4. Okay, so D equals 4. All right, now we can use that to build explicit and recursive. So like we said, for explicit, we know our formula is AN equals A1 plus D n minus 1. So now we just plug and chug. So A1 is negative 6 plus 4n minus 1. Do some quick distributive property to simplify. So you get an equals negative 6, and then plus 4n minus 4. So then we can just simplify there. That gives us an equals negative 10 plus 4n. And there we go. We have our formula. Now for the recursive, remember it's an equals an minus 1 plus d, and then you got to tell me what a1 is. So it'd be an is an minus 1 plus 4, and then a1 has to equal negative 6. So hip hip hooray for recursive, that's a lot faster. Alrighty, one more example, then we'll be done. So let's see, a1 has to equal 15. The difference between each one of these, we're taking away 8. We're subtracting 8 every single time. So that means that d has to equal negative 8. And obviously here I'm going to skip a little steps. So for my explicit, I'm not going to rewrite the formula anymore. This would be an equals 15, and then minus 8n minus 1. Normally it's plus 8, but of course it's negative. And so distributive property, so you have an equals 15, negative 8n plus 8. So an has to equal, let's say it's going to be 23 minus 8n. That is my explicit formula. Plug in any number and you got it. Now for recursive, that was the easier of the bunch. That would be an equals an minus 1 minus 8, instead of, like, it's plus d, so you're subtracting 8. And then that a1 has to equal 15, because that's where we start. And there we go. We are done with how to create arithmetic sequences. Classwork is on the next page. Thank you so much. I'll see you all later.